nucleophilic
Yes, nucleophilic substitution, right? So I'm gonna pick
addition.
up from there. Substitution है, addition reactions है, aldehydes ketones के लिए. Okay.
Nucleophilic addition था, substitution.
Yes.
नहीं था.
Wherever there's a double bond, there's usually addition reactions happening there. Yeah. So nucleophilic addition, you have C double bond O, whether it's aldehyde or ketone, same thing in terms of mechanism. This has a slight positive charge, this has a slight negative charge. So the nucleophile that attacks gets attached to the carbon, and oxygen more often than not gets hydrogen, but yeah, the positive ion that happens to be with the nucleophile goes to oxygen. Okay, so we were looking at specific cases, right? The first one was addition of HCN. So when you add HCN to aldehydes or ketones, what do you get?
You get like the cyanohydride.
So these sort of reactions, the key is figure out which is your nucleophile. So HCN is pretty convenient. You know that, okay, this breaks in
plus and minus. So isonitrile, no. Yeah. Cyanide minus will be your
cyanide ion, hydrogen ion, yeah. Or this is the nitrile group. So once you have the plus minus, follow this formula, add it there. So you get C, यहाँ पे CN gets added, and यहाँ पे O is already there, H is added to this O. Yeah. So write it a little more neatly. What you end up getting is tetrahedral OH CN. The rest of it, whatever is here, remains the same. So if it's acetone, CH3 रहेगा. Aldehyde है तो R and H रहेगा. So this is called cyanohydrin. Name is also very, very literal. Cyano, there's a cyano group. Hydroxy से hydrin आ गया, OH है. This is cyanohydrin. Okay, next we have addition of a bisulfide group, NaHSO3. Again, same funda. NaHSO3. So यहाँ पे what is the positive part, which is the nucleophile?
So H plus, no, Na plus, oh, sorry, my bad. Na plus, HSO3 minus.
Yes. Attaches at the sulfate part of it. That's negative charge. Sorry, sulfate, like one of the oxygens. Sulfate is a central atom. Okay. So this gives, this becomes ONA, and this becomes OS.
SO2, SO2H.
Remaining SO3 plus एक oxygen is attached here, so remaining SO2 and H will be there. So this will undergo a proton transfer. So eventually you end up with an OH anyway, and this becomes SO2N. So the net result, if you see, this looks like H plus release hua and the rest of it is attached. But in reality, the mechanism is that this splits the way an ionic compound splits, Na plus and bisulfite ion. But बाद में there's an extra step of a proton transfer going on there. Yeah. So this again, like we discussed, the significance of this reaction is this is used in the
purification of aldehydes and ketones. Yes, ma'am.
So purification, because when you treat this with a mineral acid.
Miss, I'm sorry to interrupt, but I am unable to access any of the recordings of class. Chemistry, physics, or math.
Oh. How are you trying? Like, where are you trying it from?
I click on the link that is there in the description of the WhatsApp group.
Okay. So it's not there in that playlist?
No, it is not there in the playlist.
Okay. I'll get that taken care of. So videos are getting uploaded, but I don't think they're being added to those particular playlists. So I'll do them. I'll get them done. Right
Yeah,
away.
because sometimes, some topic I've written, but I don't remember what you taught about it. So
Hmm.
I have to go back, but then I don't know where to go.
Access it on the channel, but actually let me just ping. I'll tell her right away.
And sorry for disturbing. I suddenly realized it.
No, that's fine. That's fine because like सबको that everyone would be having that no to access the videos. Okay, we'll get that taken care of. Cool. So in a pinch, if you're not able to access it directly in the playlist, just go to the channel. Like all the videos will be published in the channel itself. Yeah. So otherwise, yeah, as you said, like put in a word and then we'll get it done at some point. Okay. All right. Coming back to this, used in purification of aldehydes ketones, because from this product you get your original one back. And clearly, ye wala reaction is going to happen only with aldehydes ketones. So you make it react, filter for this product alone. Whatever other impurities are there, they won't react. So you can like get rid of them and then yeah, get this back. Okay. So the next addition reaction we look at is Grignard's reagent. Hi Ansh, what happened? Ansh Gupta, are you there? Hi, yeah. What happened? Why late today?
When I was sleeping, I got a bad foot.
Okay. So just like put a message or something, no? If then instead of yeah. Okay. Coming to Grignard's reagent addition. So nucleophilic addition matlab. Okay, first of all, do you remember what is Grignard's reagent?
rmgx.
So इसमें which part will have the negative charge, which part will have the positive charge?
Mg will have positive charge, R will have negative charge.
There you go. So Mg being electropositive, इस bond में polarity होगा. So now can you predict the product? क्या मिलेगा end of this thing? Oh.
You will get like a cyanohydrin thing only that there'll be mgx attached to the O and C will be attached to the R will be attached to C.
Yes. Okay. So this on hydrolysis, actually you treat it with any base. Now again, ionic covalent, like magnesium will want to break away as like at the slightest hint of any sort of provocation. So when you do hydrolysis of this, you make it like treat it with water, with alcohol, with acid, whatever it may be, you end up getting an alcohol plus MgOHX. So this varies depending on what reagent you're taking here, but essentially this is the main thing that you need to focus on. Okay? So based on whatever is happening here, you started off with aldehyde or a ketone. And what is the final product that you ended up with?
Alcohol.
Alcohol. So this is a method of preparation. So can you figure out any special detail about this alcohol?
Special detail that it's a secondary alcohol.
Yeah. So depending on whether you take an aldehyde or a ketone, you always get a secondary or tertiary alcohol. So if you take a ketone, यहाँ पे भी carbon ही है. So there's a third carbon chain that's getting bonded over here. So you get a tertiary alcohol. If I take an aldehyde, यहाँ पे carbon है, यहाँ पे hydrogen है, you end up getting a secondary alcohol. Suppose you want
formaldehyde is the exception, which gives us a primary alcohol, correct?
Correct, yes. So if you take formaldehyde, then this is a method of preparation for primary alcohol. Okay. So you can make like custom alcohols from this. So especially just if you fix this to be formaldehyde, which is HCHO, then depending on what alkyl, like what you prepare the Grignard reagent with, then you can get that specific alcohol, like specific primary alcohol. So if you want 1-butanol, prepare Grignard with propane and HCHO, then you get 4 carbon atom ka chain over here. So if you want specifically 1-octanol, then 7 carbon chain here, formaldehyde here, and you'll get it there. Okay. So yeah, so this is reaction with Grignard reagent. The next one is nucleophilic addition of alcohols. Mechanism is essentially the same. You have aldehyde or a ketone. When you treat it with an alcohol, let's say R dash, actually, we'll take aldehydes and ketones separately in this case, because the name of the product and the constituent, like that will change. Let's say this is R, C, double bond OH. And let's say we're adding R dash OH in the presence of HCl gas. So specifically HCl gas, because we don't want like moisture here. Again, this is nucleophilic addition. So what do you predict? So before you predict product, alcohol may, which side would be like, yeah, what is the
R plus O minus. R plus O minus.
No. So it breaks down at R dash O minus.
O minus and H plus. Sorry, no right.
Yeah. So this nucleophile is like, this is the strongest base. Okay. So now R dash O minus is a negative charge, so that attaches itself to the carbon, and H plus attaches itself to the oxygen. So you get a structure like this: R, H, OH, and OR dash. So this particular configuration, like this particular kind of this thing, is called a hemiacetal. Yeah. So if you take it further, the next step of the reaction, you still have this reagent left in your beaker. Then what happens is, again, R dash OH, presence of H plus. I will get this R will remain as it is. CH, so this part is unchanged. Yahan pe 1 OR dash is attached. This OH also gets substituted. This becomes OR dash again, plus H2O. Okay. So this particular compound is called an acetal. So yahan pe the minus, this gets attached to the carbon, hydrogen to oxygen, addition reaction hua. In the second step, there is, it's basically kind of like an elimination reaction taking place. Yeah. So there is water molecule being eliminated from here. So this H2O is coming from here. Riti, all good? You fine? Okay. You noting?
Miss, it's just that my sugars are a little high today, so my head is fuzzy.
Oh. Hmm.
Done, ma'am.
Okay. Shantanu Ansh, let me know when you guys also have noted. And kind of like study the reaction, see what is happening, kahan pe addition ho raha hai, where substitution is taking place. So ketones also follows the exact same mechanism, but it just has a different name because this structure is like different in case of a ketone. Okay. So Ansh and Shantanu, I'm just waiting for you guys. Once you're done, we'll look at the ketone wala
And
reaction.
what would be the case in ketones? Like R dash O minus
Same thing.
OH, R dash, same alcohol will be added, right?
Yeah. So this side
it'll
of the reaction it will be the same. It's only it's only this side that will be slightly different.
So it'll be RCOH and OR. No, wait, I'm not so sure.
Everything is the same. I'll just write.
So it'll become like a tertiary alcohol.
Yeah.
Okay.
Ketone, you have R, and then let's take R. It could be same, could be different, but yeah. Same thing. R dash OH, the presence of HCl. Then you get R. Or if you take R dash here, let's take R double dash.
Then you get OH and
R double dash.
OR.
Get a tertiary. So this is a hemiacetal. So this is a hemiketal.
And then again, it will undergo.
Yeah, on further like substitution, then you get R dash, and upar ek OR double dash, J ek OR double dash. So basically, this is called then this will be called a ketal. So acetals and ketones. So aldehyde से आ रहा है तो acetals, ketone से आ रहा है तो ketal.
Can you show us like a 3D structure of a ketal or a hemiacetal? Because I'm not sure what to look for.
Oh.
Like I can't visualize the structure.
Tetrahedral carbon, just that on one side. Okay. This is like slightly, it looks complicated. Let me show you guys. Is it visible, this one? If I open in a new tab, it looks to be a tiny image.
So I'm guessing that's methyl group. Is it?
I'll write it and I'll show you. So acetals, okay, this is an acetal, what is being displayed here. So acetal may you have a carbon, then on one side you have the R. Let's say R is methyl. So here what is shown is a methyl group. And then aldehyde se hai, to ek hydrogen hoga attached to this thing. Now where the double bond oxygen is there, that got replaced with OR dash. So यहाँ पे they took the alcohol to be ethyl alcohol. So you have C2H5. And then the same thing is the fourth bond, OC2H5. So that's what it is. So this is the central carbon, this gray blob. So this is this carbon. Attached to the methyl group, this is from your original aldehyde, which remained as it is. And this is the hydrogen that was arranged, that was there in the original aldehyde. Then remaining two bonds of this carbon, tetrahedral structure, 1, 2, 3, 4. So the red is the oxygen on both the sides, and the rest of the thing from the alcohol part of it. So OR dash, OR dash.
Yes, ma'am, got it.
Yeah.
Yeah, ma'am.
Cool. So instead of a hydrogen here, if this central carbon is attached to two of the methyl groups, then you get a ketone. Okay. I'll give you guys a reaction. So let's take acetone, double bond O, and treat it with ethylene glycol. Suppose it's a glycol. So glycol is when you have oxygens, like not a single OH group, but you have multiple on this thing. So this is ethylene glycol. Same thing, presence of HCl gas with dilute HCl, H plus hai matlab. What would be the product?
Ma'am, here, because there is like, okay, wait.
Ansh and Shantanu, you guys have been quiet from the beginning. How's it going?
Yes, ma'am.
Okay. So wherever you have a doubt, if you're not following and if you haven't noted down, whatever the case is, yeah, ask, keep talking. Okay.
Ma'am, you want us to give the final product, right?
Huh. So you can guide me. क्या लिखूं, कैसे लिखूं?
So I'm just a bit confused here because here we'll get 2 hydrogen atoms.
Will
If
remain.
it,
Okay. Yeah.
yeah, that side of it will remain the same. On this side, OH will get from 1 hydrogen atom. So it will attach itself there, and then either the remaining, which does not really make sense what I'm trying to say, either the remaining will entirely attach itself there, or we'll get is like, I'm not sure. That's where I'm confused.
Your hunch is
But
right.
we'll get a tertiary alcohol.
What happens is, no, you won't get, you'll get a cyclical structure.
Cyclical.
Yeah. So what happens is oxygen hai. So यहाँ पे OR dash, right? So you have
Yes.
H2, then CH2, OH is there, right? So that OH kind of, forms this sort of a thing here. So this is the final structure that you end up getting. So what's happening here? OR dash attach hua, OR dash and OH. Now this H is getting eliminated with a second alcohol, say, and then यहाँ पे दूसरा OR dash है. In this case, you didn't need to get a whole new molecule in, because there is a second OH right here. So that elimination happens with.
So then we'll get plus hydrogen gas, right?
Plus H2.
Oh, H2O. Oh yeah.
तो इसका एक oxygen है, इसका एक oxygen है, and then one of these oxygen goes away during this elimination.
Can you name the structure?
So this is a ketol again, because ketone se aaya hai 2 carbon atoms. And because you got it from ethylene glycol, this is called an ethylene glycol ketol.
Okay, ma'am.
So in this set of reactions, the significance of this dry HCl, like why do we specify that it's HCl gas or dry HCl, is because, so the dry HCl is the one that protonates this oxygen. That is the one initiating the reaction. That H turns this part into an OH and then takes the reaction forward. So the dry HCl protonates the oxygen in C double bond O, and this increases the nucleophilicity of the carbon. So the attracting tendency to, like, it becomes more attractive to a nucleophile. So another note about acetals and ketols is that, again, just like your previous reaction with bisulfate addition, acetals and ketols on hydrolysis, like hydrolysis with mineral acids, you get aldehydes and ketones back. Okay, just reverse of that reaction. And then we have the final thing, addition of ammonia and derivatives. So once you're all done noting this down, and once you're done with this, then we look at
Done, ma'am.
Okay.
Done, ma'am.
Ansh, Shantanu?
Done.
Done. Okay. Shantanu? Hello, Shantanu? You need a minute or you done? Shantanu, are you there? We'll go forward. All right. The last one, addition of ammonia and its derivatives. So when I talk about derivatives, things that have a nitrogen and hydrogen, like compounds containing nitrogen that you can say with single bonds. So apart from NH3, it could be RNH2. Amines are a derivative. It could be R2NH. So the different forms of amines. So generally derivatives of ammonia, matlab you have NH2 and Z, where Z can represent another, any like covalent group. Could be an alkyl group, it could be an OH group, anything. So basically they have this sort of a structure, derivatives. So they are derived from ammonia. Okay. So you can look at structures which remind you of ammonia. Okay. So for ammonia ka derivative. So again, the key in this is to identify what would be your negative and positive side of things. Like what would be your nucleophile in this? Where do you think the bond is going to break?
Nitrogen will be minus, right?
Yes. So nitrogen ke paas hoga minus. What is the positive part that gets added to oxygen?
Hydrogen or Z.
Those are the only alternatives.
Yes.
Hydrogen. More often than not, it's hydrogen only. These kind of situations. Yeah. So you can predict the product. See, I keep using reversible arrow always in the first step because we discussed this previous class. First step is the slow step, like that needs to happen. Then the second step is like pushed.
Yeah.
Okay. All right. So you have OH and यहाँ पे NHZ. Okay. And this on hydrolysis. So this can be converted again. There is elimination of water again, and this ends up turning into C double bond N Z plus H2O. So the water from a ammonia derivative group and this OH. So these two get eliminated. So these are also sometimes called nucleophilic substitution and elimination reaction. Because पहला step में substitution है, sorry, addition and then elimination reaction. क्योंकि पहला step में addition हो रहा है, दूसरा step में elimination हो रहा है. Okay, so this can be applied to alcohol wala. Yeah. Nucleophilic
So
addition.
there are these types of reactions for ammonia derivatives, right?
Yeah. So depending on which derivative you have, like
Yeah. So are we going to do all of that?
I'll show you guys the table. Like I think all in one way, they just gave it as a flow chart sort of a thing. It's the same pattern everywhere. This is like you can think of it as a generalized template. Depending on which ammonia compound you're using, this particular part is going to vary. Okay. So once you have noted this down, I'll show you the different cases for ammonia derivative reactions. Okay, Riddhi, Mitali, you're done. Ansh, Shantanu.
Ma'am.
Okay.
Yes, ma'am.
Okay, excellent. here. So you have the aldehyde ketone group, the C double bond O, depending on what ammonia compound you take. So the first one, so NH2, single bond NH2. So this N2H4 is called hydrazine. This is rocket fuel, by the way. It's like a source of hydrogen. And then you have oxygen in a separate tank. Use it as rocket fuel. But you can see end of the reaction, C double bond N aa gaya. So what NH2 attached is another NH2. So that remained here as it is, plus water. Okay. Simple ammonia ke saath, again, same thing. C double bond N aa gaya. And on the other side, there's what H. So that remained as it is. So R NH2, like instead of Z, we have R. So C double bond N, and what is attached to nitrogen is R. So that remained. So the template is the exact same thing. You need to notice. So first step may, like in the addition reaction, wo, like from the reagent, remove one hydrogen. And then the second step, that becomes a double bond. So remove another hydrogen. So basically, beginning to end, two hydrogens are removed. And C double bond O ke place mein C double bond N aa gaya. So you have water being removed. And from the remaining thing, you can form your compound. Hydroxylamine, C double bond N, and remove the two hydrogens, you have N and OH left. That way. Yeah. So whatever reagent you are given, if there is like NH2 something, then the two hydrogens are removed and then you get your final compound.
Ma'am, if we don't have two hydrogens, then this reaction will not take place.
So the first step, addition to hoga hi, depending on what is the other thing.
Yeah, but like then it might stop or the elimination might not take place.
Yeah, elimination might not take place depending on what you have there. Yeah. Yeah, so this is the set of reactions. You guys wanna like write this flow chart so that you have your understanding and then you go through each of the reagents?
Ma'am, write it right now or write it when, like,
Right now.
do we do it right now? Okay.
Because we're anyway studying addition, addition of ammonia derivatives, right? So साथ में साथ हो जाएगा, you'll have. So depending on how it's convenient for you, either you can list it down as a list, key reaction number 1, 2, 3, 4.
Yeah, I will do that.
Or you can copy it as it is, depending on how it's.
No,
easy for you to-
no, it's easier to note it and understand it like 1, 2, 3, 4, point wise, sort of point wise.
Yeah. Cool. Let me know when you have written it all down, then we'll. Yeah. Next set of reactions, oxidation. So oxidation, two parts to it. Like the funda is like when you oxidize C double bond O, what do you get?
Carboxylic acids.
Carboxylic acids, yes. No matter what, you end up getting carboxylic acids. Okay. So set of reactions, one set of reactions is your classic oxidation, where you use your potassium permanganate, dichromate, all of that stuff. And then apart from that, you use other like extremely characteristic reactions of aldehydes and ketones. So if you look at the reaction mechanism, ho raha hai oxidation, but externally it's like there's a silver mirror test, there's like red color precipitate form. So they're used as test for aldehydes and ketones. Check for the presence of C double bond O group. Yeah. So those are like the two sets of reactions we'll look at. Your classic oxidation. So if you oxidize aldehydes, addition of oxygen, you get carboxylic acids. This is pretty simple and straightforward, like C double bond O H A. The oxygen, like oxidation happens over here, basically. This turns into C double bond O OH. End of the chain hai, pretty simple and straightforward. And the kind of oxidizing agents you use are you can use HNO3. Oh yeah, nitric acid is an excellent oxidizing agent. Potassium permanganate, KMNO4, dilute, strong, usually strong, hot, acidified, potassium dicarbonate. So this is the final thing. There's no like controlled oxidation, uncontrolled, like aldehydes hai, so you end up getting carboxylic acids, nothing beyond that. Okay. Ketones are slightly special because in the case of ketones, you don't have a hydrogen that you can oxidize directly. So it gets a little dicey there. So when you oxidize ketones, the carbon-carbon bond is broken. So it's not as simple as CHO turning into COH because it's in the middle of the chain. And ketones don't get oxidized easily. You need strong oxidizing agents and you need high temperatures for this reaction to take place. Okay, so this is quite important. They don't get oxidized easily enough. So there's no like standard set of products that you get for ketones. You end up getting carboxylic acids, but which specific acids depends on, you know, which bonds are broken. You end up getting like a mixture of products. So for
So,
example,
but like for both of them, you get carboxylic acids, right?
yes,
Like a mixture of two carboxylic acids.
it could be a mixture of two, mixture of three. It depends on
Yeah.
what. Okay. So suppose this is your ketone that you took. On oxidation, you get so either it can like, okay, acetone ke case mein it's pretty simple. Either it can break here or it can break here. But if I take a slightly bigger carboxylic acid, let's say I take CH2 R dash CH2 यहाँ पे R है. So I can take, I may get RCOH, like if the bond broke here. Like it depends on where the C double bond O goes. Then this gets oxidized. Then this also gets oxidized. You get, it's a very plus R dash CH2 COH.
Oh, that's okay for me. No. But yeah, that's not it, right? Sorry.
All fine. Okay. So let me color code it so it's easy to follow. So which products are formed depends on which CC bonds are broken. So if this bond is broken, then this gets oxidized to COH and this gets oxidized to COH. So you get RCOH and R dash CH2COH. If this bond breaks, then you get the pink May products. You get R dash COH and R CH2 COH. Yeah, so if the blue color line is where the carbon-carbon bond broke, then the blue products are the ones you get. If this bond breaks, you get this thing. So all in all, yeah, like oxidation of ketones, you end up getting a mix of products. Mix of acids depending on which CC bond is broken. So this is simple, straightforward oxidation. So once you're done with this, then we look at named reactions for this. Okay, so Mitali's done. Dhriti, Ansh, Shantanu.
Miss, 1 second, I'm writing the last. Done, ma'am.
Done, ma'am.
Done. Okay, awesome.
Done, ma'am.
Cool. So the first of these tests is tolerance test. Also called silver mirror test. So this gives you a hint as to what do we have in that test also. Okay. So this is the basic reaction. This is what happens usually. Tolerance test, you have an aldehyde, RCHO. So tolerance reagent, which is what you do tolerance test with, is chemically it is this. It's slightly, it looks complicated, but it's not. So this is a complex with silver bonded to ammonia, the positive charge. So the name, so this is tolerance reagent. So chemical name of this, so this is basically ammoniacal silver nitrate solution. Okay, so you take some silver nitrate, mix ammonia in it, you end up getting this complex. So this we represent this with the positive charge because this complex is the one taking part in the reaction. To keep it neutral, you also have the NO3 minus anion, but like we ignore that because this is the main thing that ends up taking part in the reaction. Okay, so you mix ammonia with silver nitrate, you get ammoniacal silver nitrate solution. It's a complex. Like how much of coordination compounds have you guys followed or remember that chapter?
Much of it, because like recently did it again.
Oh, that's good. What about the rest of you? Dhriti, Ansh?
Ma'am, we haven't covered coordination compounds, right?
We haven't, no.
No, we haven't done it.
That's why I'm asking you guys, like school say, how much do you remember? How did you follow? Because if you did, you
Thoda
did
bahut
consider
follow
it.
hua.
So this is a complex that's formed.
Yes, ma'am.
Molecules.
Miss, it's not like एकदम नहीं समझा, but you know, retain नहीं हुआ. समझ गया.
Yeah, that's
You
fine.
want us to name that?
Huh?
You want us to name that?
No, not right now. As long as you're familiar and you kind of understand
Yes,
why
ma'am.
the square brackets.
Why is it in a bracket? Yeah, okay. Yes, ma'am.
Yeah, ammoniacal silver nitrate. Nitrate part, not important. This is the one that takes part in the reaction. Let's focus on this. Okay. And solution here, like, so you have H plus OH minus. So 3 OH minus. So this is the oxidizing agent. After oxidation, naturally aldehydes gets oxidized to COO minus. Plus silver is reduced to Ag plus. You don't have the ammonia with it. And you get water and ammonia back. Balance करने के लिए this needs to have to, yeah, this is the thing. So this is the tolerance test ka chemical reaction. What happens? Ag plus ne, sorry, silver ions ne, silver gets reduced. यहाँ पे ionic form है ना, so it gets reduced to elemental silver. So the elemental silver, this is the important part. So if this reaction happens, so if aldehydes are oxidized, silver is reduced. So when you're doing it in a test tube, so this is characterized by the formation of like silver produce hua na, so it looks like test tube pe ek mirror hai, call it silver mirror. That's why it's called a silver mirror test, because if the test, if there is an aldehyde, either an aliphatic or like as long as you have that CHO group, you can easily just a second. Yeah, if you have that CHO group, it gives the test, you end up like the silver mirror ends up forming. So yeah, it's called a silver mirror test. So once you've noted it down, I'll show you the visual of it, like what it looks like and all.
Done, ma'am.
And okay. So silver mirror test is used to test for aldehydic groups. So ketones don't give it readily because you need that oxidation to see. All right, showing you guys this thing. Yeah. This is what it looks like. So solution is transparent, but at the end of the reaction, it kind of looks like you have a mirror there. So let's see if
Some
the,
tolerance test is only given by aldehydes, right?
yeah, it's used to test for aldehydes. So both regular aldehydes and aromatic aldehydes give this test. Primarily.
So I've got my essay written, and I've been working on it for about a week. So now I'm going to show you how I use Grammarly to...
And this guy,
Using Tollens
he
reagent
pops up
test
so
for
many times,
aldehyde.
it's annoying.
I'll skip directly to the reaction. There you go.
This video first demonstrates the preparation of Tollens reagent.
So you prepare it then and there itself.
Two tests will then be carried out. One shows a positive result, and the other shows a negative result. Preparation of Tollens reagent.
So you mix silver nitrate.
2 milliliters of 0.3 molar silver nitrate solution into a clean test tube. And then add 1 to 2 drops of 0.3 molar sodium hydroxide solution.
For the OH.
Brownish precipitate of silver oxide will be formed. Add a 3 molar aqueous ammonia solution drop by drop with a dropper, until all the silver oxide precipitate is just dissolved.
Yeah.
Do not add excess amount of the ammonia solution. The solution obtained is aqueous diamine silver solution, which is also known as Tollens reagent.
So aqueous diamine silver solution. So if you look at the complex we've written, there's 2NH3 diamine silver solution.
Add a small amount of sample to the Tollens reagent. Shake the mixture gently, and then stand it on the bench for 10 minutes. Observe if there is a silver coating formed on the inner surface of the test tube. If there is no observable change, warm the mixture in a warm water bath for 5 minutes. If the sample is an aldehyde, a positive test result will be obtained.
So there you go, silver mirror.
If the sample is not an aldehyde, the test will give a negative result.
You do the same thing. So there's nothing formed.
It is important that Tollens reagent should be freshly prepared.
This is an important point there.
Prior to disposal, the reagent must be acidified immediately after use.
Disposal techniques. Like if you were actually doing the reaction, you need to take all these precautions in the lab. Okay. Do you guys have this in practical silver mirror test?
Yes, ma'am, we do. But like it wasn't it we didn't do it, it was shown. It was shown.
Only this test was shown. Other all tests we did on our own.
Okay. Other ones you guys
Because
did
Miss
it.
said the alcohol thing would pop, and the gas is dangerous if it falls on your hand or something. I didn't still get the reason, but okay, whatever. At least we did like
Reason.
so many of them.
Cool. Okay, so this is Tollens test, also called silver mirror test because of the characteristic silver mirror you get there. Okay, so things you need to remember is one, क्या हो रहा है test में oxidation of aldehydes. So aldehydes oxidize हो रहा है, इसलिए silver itself is getting reduced. Silver is the oxidizing agent here. Two, you need to know what is Tollens reagent, ammonical silver nitrate solution. You get it by mixing. You prepare silver nitrate, make it slightly basic for OH, and mix it with ammonia. So that's the important part. It needs to be freshly prepared. And then three, what gives the test, what does not? It is given by aldehydes only. It's a test for aldehydes. Ketones do not give it. And result is the formation of silver mirror. How do you identify it? Okay. So this is one. And there is another one similar, like prepare the reagent freshly and all of that stuff. So that's Felling's test. So Felling's test goes one step further. इसमें all types of aldehydes give the test, but Felling's reagent के साथ aromatic aldehydes don't respond to it. So only aliphatic aldehydes respond to it. So benzaldehyde will not give the test. So Felling's test is slightly more complicated than Tollens test. So Felling's test करने से पहले you need to first prepare, get all your ingredients together. So you have Felling A, which is aqueous copper sulfate. And you have Felling B, which is alkaline potassium tartrate. Do you guys remember tartric acid?
No, ma'am.
Yeah, so you prepare potassium tartrate from tartric acid. Iska common name hai, this is also called Rochelle's salt. Okay. So mix A and B, like prepare these two solutions, then you mix A and B solutions in equal amounts just before the test. So just like how you prepare Tollens reagent when you're doing it, this also needs to be freshly prepared. So you take some Felling A, which is normal, like aqueous copper sulfate you have lying around. Then you pick alkaline potassium tartrate, so Rochelle's salt, and then mix both of them in equal amounts. So iska reaction hai, should I write it down or should I go to the next page?
Ma'am, next page would be preferred.
Okay.
Miss, but just 1 second, leave this
Yeah.
page I'm writing.
Yeah.
Done, ma'am.
This for Felling's test. Okay. Shantanu's gotten disconnected. It's been having network issues. Ansh, you also done?
Yes, ma'am.
Okay. Okay. So the reaction for Felling's test is this. Again, you take your aldehyde, your sample. If it is an aldehyde, this is the reaction that will take place. Remember, we mixed copper sulfate, we mixed potassium tartrate, alkaline potassium tartrate. So you have copper ions in the solution and alkaline solution here, you have OH minus, gives, if that's an aldehyde, it will get oxidized easily to carboxylic acid. And copper from Cu2 plus, it is reduced to Cu plus. So you have Cu2O and 3H2O. Okay. So this has a characteristic color. So copper oxide is a red brown precipitate. Okay. So if this reaction is taking place, then copper gets reduced from 2 plus to like cupric to cuprous. So yeah, so when you have Cu plus, you have Cu2O formed in this process, which is a red brown precipitate. So you won't get a red brown precipitate if this test is not given, because that means that this is not oxidized. So as I mentioned earlier, aromatic aldehydes do not give this test. You don't end up getting the precipitate with aromatic aldehydes. So if you want, you can note down this detail. So Cu2 plus, like when you take copper sulfate and in general Cu2 plus salts, this is like a bright blue in color. So when blue changes to red, that's like a proper noticeable detectable change you have there. So let me know when you're done. We'll show you guys this thing. Hi Shantanu. Shantanu, watch the recording again. Like you've been coming on and off and catch up. Okay.
Yes, ma'am.
Dhriti, Ansh, once you guys are finished noting down.
Done, not done.
Okay.
I'm done too.
Okay. Yeah. So first, this is the difference. Like copper salts are blue in color, but once it's reduced to Cu plus, this is the color of the precipitate that is formed. So positive Felling's test is red, negative is blue. Okay. And this is what the test looks like. So you have Felling A and Felling B.
And 2. Feeling 1 is made of 7 grams of copper sulfate and 100 milliliters of distilled water. Feeling 2 is made of 35 grams of potassium sodium tartrate, 10 grams of sodium hydroxide, and 100 milliliters of distilled water. For the test, both solutions are mixed, so the copper and the tartrate ions react to form a deep blue complex. The volumetric mixing ratio is 1:1.
So equal amounts of both the solutions are mixed. If you want to note it down, this is the structure of the complex that ends up forming from copper sulfate, and this is the, like, copper sulfate has copper ion.
Miss, because we have done the practicals, I mean, I can actually relate to what is happening here.
Ah, okay. That's cool. Yeah, that's nice. Like a lot of this makes sense. If
No,
you
because we did all these tests.
The copper
you know,
ions
Felling's
in the
test
copper.
and Tolling's test and all that.
good, good. That's good. Have you also done salt analysis? Nice.
Yeah,
ma'am.
ma'am.
Inorganic also will make like all these tests for all these different metals and all. That should be easy now. If you've seen it.
Yes, ma'am.
Like, do you want to continue seeing this or should we skip?
No, ma'am, it's
Can we
okay.
finish the
We got
video?
the gist.
Can we finish it off?
Okay.
Complex is easily reduced by many reducing compounds. Commonly, the Fehling's reagent is used to test for reducing sugars. For this, the reactions of glucose and sucrose with the Fehling's reagent are compared. 3 test tubes are used. To the first one, some glucose is added. Sugars are also called saccharides. Glucose is a monosaccharide or single.
So that's another use for this test. Since we are studying in context of aldehydes, ketones, used to test for aldehydes. It's also used to test for reducing sugars, like sugars that can reduce.
Sugar. To the other 2 test tubes, sucrose is added, which is also known as household sugar. This is a disaccharide or double sugar. It is made of glucose and fructose, which are connected by a glycosidic bond. To the third test tube, a small amount of citric acid is also added. Then all samples are dissolved in some distilled water. Next, the beaker is filled with boiling hot water and the test tube containing the sucrose and citric acid is heated for a minimum of 2 to 3 minutes. Then the sample can be removed from the water bath. When it has cooled down, the Fehling's reagent is added. Now all the samples are heated in a beaker with hot water. A positive result is indicated by a precipitate of copper 1 oxide that can exhibit different colors.
You can see there's an immediate change in the color as soon as it is put in.
At the end, all samples can be removed from the water bath. Glucose gives a positive result because it has an aldehyde group in its open chain form. That's why this reaction can also be used to test for aldehydes. The sucrose didn't react because the ring of the glucose cannot open due to the glycosidic bond, so it's not a reducing sugar and the result is negative.
So this you had studied it in the context of glucose back in biomolecules. You must have like silver mirror.
Yes, ma'am.
Yes,
The
ma'am.
third sample containing the sucrose and the citric acid has reacted. This is due to the glycosidic bond because it can be splitted in acidic conditions. This way, all disaccharides can be splitted into the monosaccharides. The monosaccharides then give a positive result. There are also disaccharides that are reducing sugars. An example.
Yeah, anyway, this goes on. But yeah, essentially that is Fehling's test. You prepare Fehling's reagent like freshly by mixing 2 solutions, conveniently named Fehling A, Fehling B. And yeah, the test is because copper is reduced. So blue colored Cu2 plus reduces to a red brown Cu plus copper oxide. Okay. Then we have a third test. Again, this is a test for so this is a different sort of a test. It's not specifically aldehydes or ketones. So this is called a haloform test. Have you guys done this also? Okay. So the most commonly used, what do you call? The like. So this, okay, the reagent for this test, sodium hypohalite. Hypohalite is NaH. Just NaOX. Yeah. So this is hypohalite. So hypochlorite, hypobromite, hypoiodite, DITE. Okay, so that's the suffix. It's called haloform test because the end of it you get a haloform, like chloroform, bromoform, iodoform, that way. So most commonly what is used is, it's also called an iodoform test, because iodoform is the one that's commonly used, because this has like a bright yellow color, gives a bright yellow precipitate. Yeah. Can you guys figure out the formula for iodoform?
Isn't it CHI3?
CHI3, yes. Chloroform is CHCl3, iodoform will be CHI3, because iodo is. Now coming to the test. So this is used to test for the presence of a CH3CO group. So test for CH3 C double bond O hona chahiye. So it could be an aldehyde, it could be a ketone, whatever it may be, but basically does the structure contain this particular group set of atoms, CH3CO. So if this is there, then you get a positive result for iodoform test. If this is not there, you don't. Why? Because this is the reaction. Okay, so you have CH3 C double bond O, and then let's say R, then treat it with a hypohalite, let's say NaOI, then you get R C double bond O ONA plus CHI3. Like whatever halogen you get that particular compound. NaOX liya to CHX3 hoga. Because I took iodide, I get iodoform here. And of course, like as always, you always exclude fluorine in this, but this reaction is possible with chlorine, bromine, and iodine. Specifically, iodine is the one that's used in testing for this particular thing. Okay, so the test part of it comes into picture because this iodoform is a bright yellow, as I mentioned here, bright yellow precipitate. So interestingly, so basically this can also be used to detect not just CH3CO, also CH3CHOH. So what happens is during the course of this reaction, if you have a CHOH that anyway oxidizes to C double bond O, so either this or this, like CHOH, secondary alcohols basically. So this particular,
Either it's CH3C double bond O or CH3COH.
CHOH, yeah. Iska oxidation karne pe you anyway invariably get this only, right? So in both cases, it works out. So rather than bright yellow, I think call it pale yellow. Like basically you get like a yellow color, not a dark yellow, but a lighter yellow color precipitate. Have you guys done this also in lab?
I think so, ma'am. Because I remember getting a really bright
Yeah,
yellow
we have done
PPT
this.
in a
Yeah, yeah.
test tube, and I was just like, what is wrong with this thing?
Okay.
The yellow PPT was good, and then
I think I was supposed to get something else though.
no, the yellow PPT was good. Then Miss asked me to smell it, so I, like brought it way too close
Oh,
to
it
my
smelled
nose,
so
and
bad.
then yeah, and then I dropped the test tube, so it was there all over my lab coat.
Oh my God, you guys broke so much things. We were like warned that, dude, these many people broke these many things. Please don't do anything.
No, we were the last ones to do it.
You did it today.
Yesterday.
We also did it yesterday.
So I
was
mean the yellow thing fell, then some potassium something fell on my lab coat.
Did you have a color?
I didn't take a lab coat, so I got like Alak's folder.
Yeah, there you go. You can see like result of iodoform test. You can see there's a yellow colored bit here. That's what it looks like. Okay. What else? Yeah. Whatever you did, I hope you didn't smell HCl directly, because my first lab in like 11, 12, that's what happened, and then it burned the inside of my nose.
Miss, I don't know what I smelled, but I smelled a lot of shit and it was very, very weird.
Yes.
And I would like to not do it again ever.
Yeah. It's good you
Miss,
made
the
it.
smells were like so, they're like they just hit the nose. I'm like, oh, that sort of feeling.
Remember, I was talking to you guys about formaldehyde. Very,
Yes,
very
ma'am.
like,
That's
now
not
you
very
can,
toxic.
now you can put a feeling to the words that we use, pungent odor and all of that. Now
Ma'am, we also know how to react to that pungent odor. Like we have like a characteristic thing now.
Yeah.
Also, ma'am, do you mind if I switch off my camera and like quickly gather my things, because I have to squash for like in 10 minutes.
So we have last like reactions with alpha hydrogen. Again, this is going to be a little intense. I would rather you like sit and follow. So we did nucleophilic addition. Then we did oxidation reactions, reduction reactions. Oxidation may you had all these tests. Then the fourth set of reactions, which is reactions with the alpha hydrogen. So the main thing, again, named reaction here again, not after a person. So you have aldol condensation reaction. Okay. So just like we dealt with acetals and ketones, right? That way here you get to you come across a new set of compounds, aldols and ketones. Okay. So what is special about alpha hydrogen? So suppose C double bond O hai. Now our focus shifts to the neighboring carbon atoms. So if there is at least one neighbor that has a hydrogen atom attached to it. So obviously formaldehyde, we are going to disregard. Everything else like acetaldehyde, acetone, butanol, like whatever there is. If you have like C double bond O ke neighbor mein, if there's a CH. So this particular hydrogen, the alpha hydrogen, is going to be acidic. Okay. Why can, like, how is this acidic? How do we come to that conclusion? Any idea what happens? How is this acidic?
Ma'am, because it's acidic hydrogen because can you hear me?
Yeah.
Oh, then why is it echoing?
Oh, something on your end then.
Yeah, I mean I can hear my voice twice. Okay, no ma'am. It's basically acidic hydrogen because I think it can be given out really easily.
Yes. So when there is a base attacking it, let's say we have B. So what happens is C double bond O is electron withdrawing, right? So this has a slight positive charge. So it has like inductive effect towards the neighboring carbon atoms also. It's going to try and attract electrons this way. So when this starts facing pull of electrons, it starts attracting these electrons with a greater force than what you'd find in other things. So when a base comes attacking this hydrogen, it's easy for this bond to break. So what happens is you have C double bond O, then C. When it lost the hydrogen, इसके पास negative charge आ गया. This has a resonance that is set up nicely. Okay. So you have lone pair of electrons here, you have a double bond here, then you have extra like electrons here, single bond, double bond, like because of this thing. What happens is the oxygen pulls on this pair of electrons and this migrates over here. So you end up getting C O minus double bond C. Okay. So the basically the essential the reason behind all of this happening is the C double bond O that you have, like ye wala C double bond O is electron withdrawing, pulls these electrons towards itself. So because this is electron withdrawing, it stabilizes the conjugate base. Remember conjugate base we were talking about? Acid may, if you remove the H plus, what is left, this particular anionic structure is the conjugate base. So because this is stabilized by the electron displacement, like oxygen pulling on these electrons is forming a double bond and there's a constant movement of electrons. So it doesn't mind losing the hydrogen. It's just gaining more stability in that context. So that is why the alpha hydrogen is acidic. Yeah. So this special property of this particular alpha hydrogen, you can see it in the aldol condensation reactions. Aldol condensation here, na? So different versions of this. You have aldol condensation, same reaction, you just, like a step further, you have cross aldol condensation. Once you follow aldol condensation, the cross aldol is like pretty easy. So once you've got ye wala concept, let me know, then we'll get into this reaction. Okay. Almost up for time. Okay.
Ma'am, can I leave?
In that case, yeah, we'll stop here because this is again another major reaction, just like
Yeah, aldol condensation, correct.
So in that case, we'll resume tomorrow. Yeah, it makes sense because then I can do aldol, then cross aldol, like all of them together. Okay.
Guys, one second. Tomorrow, Mithali, what time are you coming back from school?
I think it's usual only 12:45, something like that.